Hi, and this is Charity McKenzie with IDEA. I know it sounds weird that I say that on each video, but you'll hear that just in case someone randomly on YouTube finds me and watches my videos. Okay, so I am actually going to show in this video how to do fractions inside of your equations. So we're going to have fractions in equations. And these equations have multi-steps. Okay, so there's quite a few steps in and mixed with fractions. So here's my little shortcut for fractions. What I would do is multiply by the common denominator. And what this does is get rid of all of your fractions. So you can do this only in equations. You can't randomly do this when you're trying to just add fractions or a different type of problem. Only works with equations. So let me give you an example. If I have something like x over 8 minus 1/2 equals 6. Now this one's not too bad of an equation with fractions, but a lot of people go, if I add them, you got to remember to get the common denominator. If you multiply them, you got to remember that you just multiply straight across and reduce. So there's a lot of rules on fractions. So what I do is I multiply every single term by a common denominator, and that gets rid of your fractions, and then in turn makes the equation a lot easier. So look at all your denominators. I have an 8, a 2, and then there's not 1 over here. So between 8 and 2, what number do they both divide into? What would be a common denominator for those two? So if you look, it would be 8. 8 is divisible by 8, and 2 divides into 8. Okay, if you can't think of one, multiply the denominators and use that. It'll work. So my common denominator is going to be 8. Is going to be 8 for this one. Okay, so I'm going to take 8 and I'm going to multiply it by every single term. Now this is where people mess up this kind of shortcut way to do these type of problems. It's a pain to write it out, but do it, then you won't mess up. I have now written the 8 by every single term. There's an 8 now here, here, and here, and I'm going to multiply it. Now watch what happens when you multiply it. Well, our rule with multiplication, and you could think of this with fractions as over 1, is these 8s can cancel each other or divide out to a 1, okay? And then 1 times x is just 1x or x. Yay! Then I still have this minus sign. 2 divides into 8, leaving me a 4, okay? 4 times 1 would leave me a 4 over 1, or 4. And the 8 times 6 is going to leave me 48. Okay, then from here, I have a much easier equation. So look at this. All I have to do is do the opposite of minus, which would be add the 4 to both sides. And x is going to equal 52. So it seems a lot harder than it is when you have a fraction. So if you use this rule of a common denominator and you multiply every single term by that common denominator, you're going to find a lot of success with your fractions in your equations. Let's do another one. What if, I just want to do this one, even though it's a little easier one, it's so commonly messed up. I'll use a y this time. Notice the y is in the numerator on the fraction, or sometimes they write it next to it, which is the same as the numerator. It's not in the denominator. A lot harder problem if that y was in the denominator, which some of you might find if you're in the higher levels. But to start out with, when I see this, people get really confused. What you see is you see 4/6 being times by y. So what is the opposite of timesing? It is division. So to get rid of the 4/6, I'm going to divide by 4/6. The rules with fractions say flip and multiply. So I could do that pretty easy, most easier than I can dividing or multiplying by the common denominator. So what I'm going to do is I'm going to flip, and you could still use the common denominator method, but for just the one-step equations like this, you should be able to do it without the common denominator. So I'm going to flip the number always by the letter, and that's going to become 6/4, and I'm going to multiply it by both sides. And why 6/4? Because what happens over here is 4 divides into 4, leaving a 1. 6 divides into 6, leaving a 1. 1 times 1 is 1. 1y is what we have over here, okay, or just a y left. Over here, we can reduce, cross-reduce on this one too. 3 is going to divide into 6 twice. 2 is going to divide into 4 2 times. And then 2/2 actually reduces 2, which is kind of weird looking at first, but we can write it as 2/2 because we'd have 2 times 1 and then 2 times 1, which is 2/2, or it becomes 1 for y, just depending on how you reduce that fraction. So y actually equals 1 because 4/6 and 2/3 is the same number. From the beginning, you just need to reduce the 4/6, but you did not hear that yawn. Okay, so those are kind of the a couple fraction problems. Let's do one more. I'm looking in a textbook for some that I think are harder than what I've done, but I don't see one, so I'm going to make one up. Okay, what if I have 3x minus 2/3 equals 7/5? And I'm hoping this has a fractional answer. Okay, so if I look at my denominators, first of all, it's not just a one step like the second question, so you definitely need to multiply by a common denominator. So what I'm going to do is I see two denominators, 3 and 5. And you have to think of a common denominator, what do they both divide into? But like I said, you could just multiply them and that would work. So 3 times 5 is 15. It's not the least common denominator always when you do that method, but it'll always work. So I'm going to multiply them and get the common denominator to be 15. So I'm going to let CD just be the common denominator. And I'm going to take 15 and I'm going to multiply it by every single term. So like I said, writing it out is what most people don't like to do, and that's where they end up with the errors. Okay, so 15 times the 3, so 15 twice is 30. 30 plus 15 more is 45x. Then this one, we end up taking the 3, dividing into the 15, because you can think of it as 15 over 1. And that's going to go in there 5 times. So I have minus still here, 5 times 2, which is 10. And then over here, 5 is going to divide into 15 3 times. 3 times 7 is 21. And then I'm going to add the 10 over to the 21 because here's my x, and I got to get rid of that 10 first. Okay, those ones will cancel to 0, and I have 45x equals 21 plus 10 is 31. Okay, I'm on my last step. 45 times x is the same, or the opposite is going to be to divide by 45. Cancel here. And we don't want to change this to a decimal unless it's a word problem and it's asking for like something specific or they tell you to round. This would be your answer. You just have to look if you could reduce. Oh, excuse me, I can't stop yawning all of a sudden. So if I can reduce 31 over 45, well, think of 31. I can't think of anything that divides into 31. 2 doesn't, 3 doesn't, 4 doesn't, 5 doesn't. I don't think so. And the only thing that divides into 45 is like 3, 9, 5. So this is already as reduced as it's going to get. So x is going to equal 31 over 45. And normally I'd rewrite it, but I'm kind of running out of room there. All right, and it's okay to have fractional answers as well. Now to check this one would be a lot harder than probably even it took us to do the problem. But here's my little shortcut for fractions in equations.